Hello students, welcome to our online study YouTube channel. Now in this video, we are going to discuss types of adsorption isotherms. So before that, what is adsorption isotherm? The variation of adsorption with pressure at a given constant temperature is generally expressed graphically, and each curve is known as adsorption isotherm for the particular temperature. Okay, we already discussed Freundlich adsorption isotherm, Langmuir adsorption isotherm, and then we study BT equation. Okay, and then now there are 5 types of adsorption isotherms. So large number of adsorption isotherms of gases on a variety of adsorbents at different temperatures have now been determined. There are major 5 types are observed. So first type 1 corresponds to monomolecular adsorption as postulated by Langmuir. According to Langmuir, the graph should be like this. Here we take a pressure versus amount adsorbed. You can say that theta also. Okay, the graph is like this. The volume of the gas adsorbed approaches a limiting value, just enough to complete a monomolecular layer even when the gas pressure is rather low. Further increasing pressure hardly produces further rise in the amount of adsorption, but after P0 the adsorption is stopped. For example, we can say that in Langmuir adsorption isotherm we learn the monomolecular layer is formed. Consider this is the surface area, and on this surface the first layer is monomolecular layer is adsorbed. As the pressure increases, the adsorption also increases, but further increasing pressure can't adsorb any molecule. Okay, here this is the steady state. For example are furnished by adsorption of nitrogen or hydrogen on charcoal at temperature close to minus 180 degree. Here temperature is very important because we are discuss about the adsorption isotherm. Isotherm means temperature is very important. At different temperature the adsorbent shows different variety of curve. Okay, so here the temperature is very important. So now we are going to discuss about type 2 and 3. Type 2 and 3 show large deviations from Langmuir model. The amount of adsorption keeps on rising in each case with increasing pressure. This is attributed to the formation of additional layers of physically adsorbed gas molecules. And this it is postulated that gas molecules adsorbed in the first layer may hold by van der Waals forces of attraction, and a second layer of the gas molecule which in turn may hold the third layer, and so on. So consider this is the surface. On this surface the adsorbents, the gas molecules are adsorbed. Okay, if we further increase the pressure, then here the van der Waals force of attraction is at, and it attracted the second molecule. Because of the van der Waals forces, the third layer also can be possible. Okay, so here the graph is like this. Pressure versus amount adsorbed. The graph, according to graph, as the pressure increases, the amount adsorbed is also increases. Okay, this is type 2. And for type 2, the example is adsorption of nitrogen on an iron or a platinum catalyst at minus 195 degrees Celsius. See here minus 180 degrees Celsius. Therefore, the nitrogen shows type first isotherm, and if we decrease the temperature like minus 195 degrees Celsius, then the nitrogen shows type second isotherm. And for type 3, the similar process I already explained, that the surface form monomolecular layer, and due to van der Waals forces the second layer is also formed, third layer is formed, and so on till the van der Waals force acts. Okay, now for type 3, the example is furnished by adsorption of bromine on silica or alumina get at 80 degrees Celsius. Okay, look at this graph. As the pressure increases, amount adsorbed is also increases. Now the next type is type 4 and 5th have been observed in those cases in which there is a possibility of condensation of gases in the minute capillary pores of the adsorbent at pressures even below the saturation pressure P0 of the gas. Okay, one thing is that the type 1, 2 and 3 are the non-porous adsorbents, and for type 4th and 5th the adsorbent is porous material, and due to this there is the pores are observed, capillary pores are observed, and on that capillary pores the adsorption is takes place. And in this graph you can see the type 4, as the temperature increases there is the wave formation. Okay, and in type 5th also you can see here we continuously increasing pressure. After some pressure there is the increasing adsorption and it continuously increasing. Okay, how it is possible? This is on the basis of BT theory. Okay, multimolecular layer formation is observed. Okay, for type 4 the example is adsorption of benzene on silica gel at 50 degrees Celsius, and for 5th type the adsorption of water vapor on activated carbon at 100 degrees Celsius. Okay, one thing is not here. Which thing? In the case of adsorption isotherm of type 4 and 5, there is not only formation of multimolecular adsorbed layers of the gas molecules, but also the condensation of some of the gas molecules within the narrow capillary pores of the adsorbent. This latter phenomenon is known as the capillary condensation of the gas. Let me explain. Now here already I told you that the adsorbent have capillary pores. Okay, so for type 4, consider okay, this type of adsorbents are there, and on this surface the here adsorption of benzene. Okay, consider this is the silica gel, and on this silica gel the benzene molecules are getting to adsorb. So these molecules are adsorbed like this. First they adsorb on this and form first layer. Okay, and after increasing the pressure here they lowers the adsorption, because these pores then these molecules get into the pores. Okay, so after filling these pores again the adsorption is happen as you increase the pressure, and this is another layer are formed. Therefore this graph is this curve observed like this. Okay, and for this type fifth, what is the example? Water vapors on activated carbon. Okay, consider this is the activated carbon. Okay, so here what happens, the water vapors are adsorbed firstly into the pores. Okay, therefore here no amount adsorbed is absorbed. First they fill this pore surface, okay, for pores portion, and then after filling this portion, then they start adsorb onto the surface. Here after some pressure, the increasing amount adsorb. Okay, adsorption increases after some pressure. So as you increase the pressure, the multi-layers are adsorb on the surface. Okay, I hope you getting clear this point. And if you like this video, please give thumbs up and share with your friends. If you have any doubt, please share into the comment box, and don't forget to subscribe the channel. Thank you so much for watching this video.